Modern data centers are changing. With mobile and cloud computing, traffic has been increasing exponentially and overloading networks and data center infrastructure. Enterprises are scaling up to meet these challenges, but the pressure is on to reduce costs and consolidate network infrastructure. Application delivery controllers, which are the next-generation server load balancers, are the answer, since they dramatically accelerate application performance and ensure server availability while enhancing security. Your application networking equipment system design is critical. Legacy systems were designed for single-core 32-bit system architectures. The industry's recent shift toward multi-core CPU architectures has placed significant strain on these legacy ADC systems. They have to be redesigned because porting to a denser system results in problems with parallel processing and memory sharing across these multiple-core CPU subsystems. Plus, old designs use IPC, or inter-processor communications, to share memory state, which creates challenges that worsen as CPU core density increases. Each CPU core must be aware of the configuration, security, and cached objects of all the sessions processed by all the other cores. Without a shared memory design, you get a complicated mess as memory blocks proliferate, and each CPU needs to update each other's CPU's memory through IPC. Multi-core parallel processing complexity gets even more challenging as you have multiple CPUs, each with multiple cores. To understand why this is an issue, think about it like a document that multiple people need to edit. In order to retain synchronization of content for all editors on a document, every time one individual makes a revision of the document, it must be sent to all after each revision. If the only way to do this is to send the document to every individual to make their notes and changes, then have one person gather all the edits and consolidate them, it's incredibly inefficient. Time is lost, overhead is wasted, and it's virtually impossible to scale. That's what happens with the old approach to application networking design. A10 solves the problem in a different, more effective way. ACOS, our Advanced Core Operating System, is a unique multi-processing platform that scales linearly with increasing CPU core density. Our appliances use shared memory architecture to enable all CPUs simultaneous access to the same shared memory space, dramatically reducing processing overhead, which means less work for the system. So, if we extend the document analogy, it's like using cloud-based collaboration to edit the same document. Now, multiple reviewers can make changes and comments to a shared document simultaneously. Everyone can see the changes others are making and share information without delay and without having to use additional resources. It's much more efficient. For your data center application delivery controller, that means you can scale linearly to meet increased traffic demands and keep predictable application service levels, all without adding unnecessary computational or memory resources. For your business, that means an improved customer experience and reduced expenses. Now, multiple point products can be consolidated into one efficient appliance that minimizes power usage and space costs. The reality is, data traffic is going to continue to grow. With A10 technology, you have the ability to scale to meet those challenges more efficiently with a better end-user experience and superior ROI. And that means your business can move ahead. Find out more about what A10 technology can do for your enterprise and experience the performance today.